In 5, 1, go!
First, I will start with the introduction of logical implication. Logical implication shows the relationship between two logical expressions. When A implies to B is a tautology, it means that whenever A is true, B must also be true. This relationship is written as A logically implies B.
Truth table is used to prove conclusion as a tautology then said to be logically implies. If all the conclusions are true, the statement is logically implies. An argument consists of a statement or finite collection of statements called hypothesis and statement called conclusion. An argument is valid if the conjunction of its premise is logically implies the conclusion.
So for example 1, using a truth table, determine whether open bracket R implies S close bracket and not S logically implies not S. So we need to make a truth table. So for the first column is column R. So the true values are true, true, false, false. The next column is column S. The true values are true, false, true, false. So the next column is column not R. Not R is the opposite of R. So the values are false, false, true, true. The next column is column not S. Not S, this is the opposite of S. So the values are false, true, false, true. And then now the column R implies S. And implication is only false only when R is true and S is false. So the value are true, false, true, true. And then next we combine R implies S and not S using an and. So an and statement is true only when both parts are true. So the value are false, 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 true. And then the last column is we evaluate R implies S and not S implies not S. And then this implication, so the true value is true, 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 true. So since open bracket R implies S close bracket and not S implies not S is a tautology, therefore therefore open bracket R implies S close bracket and not S is logically implies to not S.
For example 2, using a truth table, determine whether S and open bracket R imply S close bracket is logically implies S. First, we find the true value of R, which we will get true, true, false, false. First, we proceed to find the true values for S, which we will get true, false, true, false. Then proceed to the next one, R in the true values for R imply S, which we will get true, false, true, true. Then proceeds to the next one. We find the true values for S and open bracket R implies S, close bracket, and we will get the true values for the expression which is true, false, true, false. And then we find the true values for the whole expression, which S and open bracket R implies S, close bracket, implies S, which we will get true, 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 true. Hence, we can conclude that since S and open bracket R implies S, close bracket, implies S is a tautology, therefore S and open bracket R implies S, close bracket, is logically equivalent to S.
Next, example 3. Using a truth table, determine not R biconditional S and R biconditional not S logically implies not S implies R. First, we construct a truth table by listing all possible truth values of the variable R and S, which are true and false. For R, true, true, false, false, and for S, true, false, true, false. Next, we determine the values of not R and not S for each row, since both negations are used in the given statements. For not R, false, false, true, true, and not S, false, true, false, true. After that, we evaluate the biconditional statement. For not R, biconditional S, false, true, true, false, and for R, biconditional not S, false, true, true, false. Then we combine these two results using the AND operator to obtain not R biconditional S and R biconditional not S. Then we got false, true, true, false. Next, we evaluate the implication. Not S implies R, which true, 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 false. Finally, we evaluate the entire implication. Not R biconditional S and R biconditional not S implies not S implies R. Finally, we got true, 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 true. From the truth table, we can see that the final column is true for all possible cases of R and S. Therefore, the statement is a tautology. In conclusion, since not R biconditional S and R biconditional not S implies not S implies R is a tautology, we can conclude that not R biconditional S and R biconditional not S logically implies not S implies R.
In conclusion, Logical implication helps in understanding how one logical expression leads to another. If the statement A implies to B is a tautology, it shows that B must be true whenever A is true. This logical relationship is expressed as A logically implies B.